I got my speaker notes. This is also zero token architecture. So for the record, zero token architecture isn't a thing. Some people think it is. Some VCs have even reached out to me. I should have taken their money anyway. So these days, I probably spend more time working with power tools than computers. I bought a really fancy track saw. If you've never seen one of those things, they're amazing. I got scared of a table saw, thought I was going to end up in the hospital. So I bought this fancy track saw, and I watched a bunch of YouTube videos, probably like 10 hours researching which one to buy, and then maybe another 50 hours figuring out how to use it. And if you watch enough YouTube videos, you all remember the scene from The Matrix where Keanu Reeves gets plugged in. He's like, oh, I know Kung Fu. That doesn't work in real life. So after 50 hours of YouTube videos, I thought I was a carpenter. So I have everything set up. I go buy all my parts. And I plug in the track saw, and I move as fast as I could, and it jumps off the track. And a spinning blade at 5,000, 10,000 RPMs coming back at you is a very scary sight. And that's the way I watch a lot of people using AI at the moment. A lot of people think they're platform engineers because they ask Claude Code to deploy a Kubernetes cluster. While it's true you have a Kubernetes cluster, it's not true that you're a platform engineer because Claude did it. And I'm watching people now, the biggest thing in the hype wave is we've gotten to the part where burn all the tokens. People are now getting this magical thing called the invoice. It's a really unique piece of technology that tells you what things actually cost. And now that people are starting to get the bill, they're starting to understand that this ain't free. $20 a month, no problem. $2,000 a month, we start asking questions. And when the token burn matches your salary, now we're being silly. And then I'm watching people build amazing products to try to figure out how to reduce token burn. Have you seen this? Are you doing this? You probably are. You're probably burning tokens to save tokens. And for someone who's out of the game, this is hilarious to watch, because I get to be a hypocrite, because I would probably be doing this too if I was still in the game. And so I'm watching people build these agents, and I ask every session that I am, what's an AI agent? Who knows what an AI agent is? Raise your hand. You know what an AI agent is? Come here. Get up here. What's an AI agent?
I have no idea.
Go sit down. So that matches my experience. People raise their hand that they know what something is, and then when you ask them what it is, they have no idea. We're going to try it one more time. Who actually knows what an AI agent is? All right, one last brave person. Come on, bring your ass here. Big round of applause for this one person. What's an AI agent?
An AI agent is basically a script that does an LLM call that then performs an action.
Good enough. He's getting fired next week. But I do like the definition. Because when I hear this loop component, I think there's loop engineering now. Anyone doing loop engineering? Have you updated your LinkedIn profile yet? All right. We have our first loop engineer. Congratulations. And so I'm watching people do these loops. And they're like, Kelsey, we don't even look at the code anymore. We just run these agentic loops. We're doing agentic development. I was like, man, how much does that cost? It's like, I don't know, man, probably a couple $100. And it just runs in the background. I'm like, well, how many do you have? And people like to brag on LinkedIn. I have 15,000 agents. I'm like, doing what? And then you look, and I'm like, man, that looks like a CI/CD pipeline to me. It's like, Kelsey, you don't get it. There's an LLM in there. I said, okay, what is it doing? Well, and I was blown away by some of these. Let me be clear. There is something there. It's not 100% stink oil. So I'm not really here to debate whether this stuff has merit or not. There's a different conversation. A human is probably the most agentic thing we've ever seen. Independent humans have their own way of thinking about things. And when I think about my career, there were different points in my career where I could actually feel the software upgrade. When I learned how to program for the first time, I felt like I was super smart. When I understood how distributed systems actually worked, I felt like I was super smart. And the more I learned, the Kelsey model improved. So you're probably looking at Kelsey version 45. And for 45 years, throughout my life, I've been accumulating this knowledge where I have my own model, it sits in my mind. And whenever I look at a problem, I draw from that experience to try to make the right decision. That's the foundation of the zero-token architecture. You can just think. Some people just start typing when presented with a problem, moving a little bit too quick. The first step is, how good is your software model? To my disappointment, when I meet people on the conference floor, I'll just ask them simple questions. What are you working on? Then I may ask a follow-up question. How are you better than you were 2 years ago? Reading new books? Learning any new skills? And surprisingly, the answer is no most of the time. Most people haven't tried new programming languages or understood different architectures and how they work. So their menu and solution range is so small that now they're outsourcing to the LLM. Nothing wrong with that. And it brings me to the next question is, who should learn these fundamental things? Should you have to learn to fly a plane before you can do air travel? That would be inappropriate, right? Pilots need to learn how to fly a plane because that's what we expect of them. But I'm at Platform Engineering Con. All of you are platform engineers, I would assume. Do you think it's appropriate that you understand how these systems work? Do you all believe that? Because I see some of y'all working, and you got 15,000 agents running, and you have no idea what they're doing. And if the system breaks, I was just in another country, I was in France, and I'm speaking at an internal conference, and a few of the platform engineers were scrambling because the company decided that no one is getting unlimited token burn anymore. And when they went to certain teams and told them, you won't be able to use unlimited tokens going forward, there was a bit of a revolt. I was like, wait, what the hell's going on? Can I sit in? I promise not to tell anyone. So keep it in this room. And those teams are like, well, there's no way we can now meet the same demand as before if you take all these tokens away. And what they didn't realize in this journey is they became codependent. Some of us are codependent on GitHub. You see people on social media, GitHub is down, what do? GitHub is down. Like, damn, we already see the status. We don't need you to tell us that GitHub is down. So you've taken a codependency, for some of us, on GitHub. GitHub down, everything stops. When the tokens go away, if that means you can't work anymore, then we have a problem. If we fast forward this 5 years from now, how many of you will actually know how to operate the systems that you're asking someone else to build for you? Forget the agents for a second. If you hired a bunch of contractors and they came in and they designed a system from your prompts, AKA Jira tickets, do you believe that you could pick it up and maintain it once they left? Have any of you ever gone through this? Hired a bunch of contractors to build the systems based on your vague understanding of the problem, and then they leave. The first thing that you all tend to do is what? Rewrite it. Because you don't understand the current system. This is where I think the foundational root of this problem is. So when I say zero-token architecture, I'm wanting people to actually, before they start burning tokens, I just want you to understand the thing you're trying to do first. I'll give you a good example. Creating database tables. How many people know how to create a database table from scratch? You're all probably lying. I believe about 2 of you all. And this is like the first time I've seen knowledge erode because of tools like an ORM. You guys know what an ORM is? Developers gave a revolt that they shall not know how databases work, and instead they'll allow their software to map their coding objects to the database and let the ORM figure it out. If you're a DBA and you saw this work, you're like, hey, why are you making queries that are 10,000 pages long just to select one column from one table? And the developer would be like, I don't know. The ORM did it. And then the DBAs will have to rewrite those queries and hard code them into the application. I'm seeing the same process being repeated. The agent is being used to create the database table. Nothing wrong with this, if you know how to do it already. And so what people are doing is say, hey, agent, make this table. And then they have all these Claude skills, and it builds the table a certain way. And then I watch them do this over and over in a loop. Anytime you want a table built, you ask the agent to do it, and it just uses inference to create a table. This is a very expensive way to create a table. And the question that I ask them is like, why wouldn't you just export the tool that creates the table once you use inference to build that thing out? And if you were to export this tool, this works for CI/CD processes, this works for generating code, this works for pretty much anything that you would want an agent to do once. Why would you not export it so that it can just run in a loop without the inference? And if you did that, then you would be using, or you would be burning less tokens to complete the same task. If I had to make, oh, I have one more minute because I'm only 15 minutes for questions because I want to debate some of these ideas. If I had to make one prediction for the future, we're going to go from burning tokens in a loop to using tokens only once to create the loop and never use inference again until we change the loop. That's it. That will be the magic stroke that makes this feasible. So all this agentic blah, 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 yes, you all will burn tokens for the next 5 years because it's fun and it's exciting. A lot of you will go out of business because of this naiveness. A lot of you will get jobs to come in and do cost optimizations. And in 5 years, you remember the thing I just told you. You will use agents the first time. You will export the results, and then you will run the results without inference on a regular-ass CPU for pennies. If you don't believe me, that's how you work. The most advanced agents on the planet. You write code once. It takes a lot of brain power to figure out exactly what you want, a little of experimentation, a few mistakes along the way. But once you dial that thing in, we turn those into libraries, frameworks, and executable binaries that don't need us to rebuild the entire application every time we want it to run. It's this little nuance that I think will change the way we approach these type of problems. That's it. Zero-token architecture is simply that one sentence. Infer once, export, and run without inference. If you can figure that out, I think you're going to build much better systems and you're going to find yourself rooted in reality. I guarantee you that one sentence is probably going to save your company tens of millions of dollars. If you go the other way, I don't think it's going to work out. I could be wrong about these ideas, so I left 15 minutes for questions. Challenge the ideas, ask me about anything, it's all fair game. We have 2 mics, I think, running around. If there are any questions, we're going to round out the talk with 15 minutes of Q&A. Who wants to go first? We have one back there, then I'll go here. You can throw the mic to them. I think they have a really good insurance policy.
Do you already try to do it? I mean, you are doing right now, or you how example to do it?
Oh, listen to the question. Are you doing this right now, or are you trying to do it? For 30 years, the entire industry has already been doing this. I remember the first time I saw a database try to scale up and hit its threshold. You all remember when databases were very expensive to run? People were running on spinning disks. We tried to get SSDs. You try to put the database on a bigger machine. And then we realized something. The app doesn't have to call the database for the same query multiple times. If you see an expensive query come through the application that might take, I don't know, call it 5 seconds to run and consume all the database resources, what do? You stick the cache results in something like Redis. And so the app looks at the query and it asks Redis, do you have a response for this query? If so, give it to me. And you get the response back in milliseconds. We've been doing this for decades. So the concept of caching is a very core computing concept. It's what your CPU is doing, it's what your hard drive is doing, it's what your developers are doing, it's what your language designers are actually doing. So this has always been a thing in computing to be very efficient. You spend lots of resources up front, and then you get the benefit of computation to do the same thing again, and then hardware can optimize that loop to remove the unnecessary branches that don't need to be there. Why are we treating an agent differently? So I agree, I will admit, an agent can do really nice things like generate a pipeline, generate a function of code. But why would you abandon the idea that the generated code should not be stuffed in a library so it can be imported and used thousands of times? Right? Would you ever pay a developer to come into your company and write a database driver from scratch every time they ran a SQL query? That would be insane. And agents don't change any of that logic.
So token-free would kind of require humans to have the full picture in our head, right? But most of the time we're rebuilding context. Like the consulting example is great, right? Like outdated docs, outdated architecture. Isn't the problem that we never really made our systems legible in the first place, like AI or not?
Good question, and I'm glad you didn't tell me before time. So Corey is one of the people I advise, so I still do advisory work. I'm still deep in the tech world, product design, go-to-market, the whole nine. And he works for a company called MassDriver. And the first time I saw this product, on the surface, it looks like one of these drag-and-drop infrastructure management tools. And the thing we don't like about those tools is they tend not to be flexible enough to do the things we want. I remember posting this on social media like a decade ago. Everyone wants a platform with one exception or one rule that they have to build it themselves. If I show you Heroku, you won't like it because it doesn't do everything you want to do. Our discipline is unconstrained. If you wanted to build a building, then there are codes and the laws of physics to adhere to. Software engineering, we just do random things and expect the platform to morph itself to support it. And so when I look back over my 25-year career, most of the things that I saw we do in the enterprise was not designed. It wasn't like we got in a room and had the big picture in mind before we decided to add Kafka to the mix. That's not how it happens. Typically, Kafka gets introduced. Why? Because your director went to a big data conference. They saw someone give a keynote about what web scale means. They came back and they want to be web scale too. And they bought a jar of Kafka sauce and started rubbing it on stuff. And if you're on the platform engineering team, you just get a new request. We need Kafka and we need it ASAP. You may not even understand why we need Kafka. You may not understand how all the other apps integrate with Kafka. You damn sure don't know how to maintain Kafka, and you don't know how to optimize Kafka. And so if you look at someone's infrastructure, it's just organically growing over time. People like me, we quit after 2 years, and we go on to the next company. And so all of these companies and all of these infrastructures are just a manifestation of people coming and going, doing ad hoc things to their infrastructure. And so instead of reflecting on that as an industry, we decided to allow AI to deal with the complexity. That's what most people are doing now. You're taking an agent like Claude or whatever you want to use, you're teaching it a bunch of skills, you're teaching it skills that you don't have, and you're hoping that it can make sense of this mess. And one thing that LLMs and classic ML is good at is dealing with unstructured things and finding correlations. That's really good at it. And the reason why I think it's working a little bit more successful now, we moved from infrastructure as code to infrastructure as data, things like Kubernetes, you have a manifest, Terraform. There's now structure to infrastructure. So yes, I'm not surprised that these tools are now being able to make sense of these things. But I don't think it's a trade-off for simplicity. I meet some companies like Kelsey, man, I love Kubernetes, I read your book, I watched all your videos. We have 3 servers, we make $1 trillion with 3 servers, but I really want to get Kubernetes installed. I say, listen to me very carefully. Do not touch Kubernetes. Run the other way. If you only have 3 servers, SSH in the for loop is in, you can't beat it. Copy that binary to your 3 servers and go on vacation. Ignore everything. Matter of fact, give me that KubeCon ticket. You shouldn't be here. Go home. And that's the honest truth for someone like that. And so I think now that you're building tools to help people visualize these things, I think once we start to visualize these things, back in my day, people used to have these Visio diagrams. You guys remember Visio? I'm old, I'm dating myself. But there was a tool like CAD where you could actually draw out all the infrastructure. And the best companies kept it updated. So when you join a platform team for the first time, you can look at their diagrams. I mean, you all think this is insane. I'm put on a different hat. If you were a construction worker and you're going to go into a building where there's hundreds of other people working on things, drywalls, floors, electrical, plumbing, what is the first thing you're going to ask for? I need to see a diagram. I don't know where the bathroom goes. In our profession, like, just put it somewhere. right? Put it next to the kitchen. There's easy water access. But that's how we design systems. And so when you have a blueprint, you can actually look at the whole thing first and say, oh, I see what we're trying to do. Fundamentally, you all are moving data around. That's what you're doing. But most of you can't see the big picture, so we just start bolting things on. And I think the mistake the industry is making is that we think AI is going to give us air cover for being able to kick that can down the road. And I think it's a drastic mistake. And so I think for most people is being able to visualize and see the whole picture before you start making decisions, or even having a picture of all the previous decisions. There's no match for having that kind of context. So if you think context is amazing for agents, wait till you give it to humans. And then we'll go here.
When I think about technology, we talk a lot about building things. We rarely talk about maintaining things. And so I wonder if the key question for us is, are we going to be happy with these systems we design on day 300? You know, if we start to look backwards from the future, are we happy? And to your point, with the bill, with the complexity, with the lack of understanding of how it works. So if we start to look at these things through, is this going to work well 3 years from now, 5 years from now? That should hopefully inform the decisions we're making today. We seem to be just focused on just bolting on more stuff. So start from maintaining the system first, work backwards.
If I were to take the statement as a question, I think the part here is that the amount of talk I'm hearing around productivity is insane. First thing I ask people that taught the productivity thing, did you get a raise? And they were like, nah. I said, oh man, you're getting ripped off. If I did 10x more work, we need to be talking about a compensation increase. And then the other thing that I do when I hear people talk about building things is I just go to their public-facing website or look at the product they actually sell to people. And typically, that thing doesn't change. So then I'm asking, where's all the productivity going, right? Are you filling out JIRA tickets faster? Are you writing tests that no one's ever going to read or care if they break? Where is this world going? In terms of the maintenance side, that's not the biggest fear that I have. The biggest fear that I have is there are millions of people who do the kind of work we do. And every decade, there's only 3 or 4 people who come up with an idea that spans the globe. And we're only batting that average with millions of people in the thick of things. And some of them look up and say, I think there's a better way to do this. And when we see it, it seems so obvious because we understand the problem so intimately. The last time this happened in my career was when Docker came out. We were all building RPMs, dev packages. Some of you all are savages. You were just shipping source code to the server with SCP. But we all had this concept of packaging things. And then we all had the concept of running things, right? Init file, systemd, maybe you're using Ansible or Chef, but we all had this concept. And for decades, we did nothing about it. All the system administrators, DevOps people, we just sat there doing the exact same thing over and over. We even brought in tools like Jenkins to help us do it faster. But we didn't think to change the abstraction, not one time. And then the developer community comes in and like, that sucks. Why would you ever want to do that? And then we got this thing called Docker. Now, Docker is not this world-changing thing that you could never imagine before, so when you saw it, it was very obvious. Make files turn into Docker files. We stopped talking about 5 different packaging systems, and you end up with one, AKA the container. And then we started to normalize how things run because they all run the same way. App starts up, makes system calls, app turned down. App have logs, send logs. And so the only reason why we got to that is because of the millions of people doing this kind of work had the insight and skill to know how to make something better. So fundamentals are at the core of innovation. If you take the fundamental understanding out of this equation, then do we just have the big AI labs, the only ones with the ability to suggest something new? And remember, that's not really how those systems are designed. Those systems are a reflection of the past normalized into a model. So if you think about it, we train the models. Every GitHub commit, every question on Quora or Substack or whatever tool you use, those are the inputs that went in to train the model. Which one of our ideas made it to the top of the prompt response? Maybe it's a normalization of all of them. But that doesn't mean it's innovative, just because it can do something you can't do. So the thing I worry about the most is, if the number of people batting, does the batting average go down? Are we stuck with the current set of programming languages? Are we stuck with YAML files? Are we stuck with these Rube Goldberg machines? Or will one of you get tired of the pain and build a better substrate that then even the AI agent will then start to operate? It doesn't work the other way. I think people get confused. Most AI agents sit as a layer on top of the existing thing. So if you have bad and terrible, hard to maintain infrastructure, your agent is just going to be sitting there dealing with bad, hard to maintain infrastructure, and just gonna burn tokens while you do it. And I think the industry is excited because they think they're gonna get that at a cheaper cost. That's the part that doesn't make sense to me. We're not done evolving computing platforms. They should still evolve. And so the question I think you gotta ask yourself is, do you need to know? If you really think your job in the future is going to be guiding agents to do the work, I doubt you're going to have a job in the future. Why? They sell these agents to everyone. There will be nothing unique about you. We got time for one more question. I think it was here.
I'm more curious on how to go about, like, what you're saying makes sense when you have the experience, right? If you, of manually doing things, you start to think in high level. But how about for like interns and junior engineers? How do you get them into this kind of?
This is the best question of the day. So for people that have experience, and a lot of people that are very excited about this technology, the one thing we're not talking about is we already have the experience. So we know what we're looking at. And so of course we can guide it in the right direction because we've done it before. But what happens if you've never done it before? I think this is super important because I think a lot of the senior engineers face this too when new things come out. We're asking ourselves, we've never done it before. So I think the best bet is I would definitely learn all the new tools 100%, but I would also be this historian. I would go and figure out how were people doing this before this tool showed up. So Kubernetes came out when I was about 32 years old. So it doesn't matter what age people start these things come out when they come out. And when Kubernetes came out, I looked at the technology, and the first thing I did was I took something that I did by hand. I wrote this guide called Kubernetes the Hard Way, just to see how everything manually fit together. And then I started saying, hey, there's a thing that I deployed a couple years ago. I did it manually. What would it take to make Kubernetes do the same thing? And then I started writing YAML files, and I got Kubernetes to do the same thing. And then I asked another question, well, then how does it work? Once Kubernetes does this thing, what's happening on the actual server? And it turns out it's exactly the same thing that it was doing when I was 18 years old and started getting into system administration for the first time. So I think for you is the fundamentals are still the same. You can't get disillusioned by the words that people use, agentic loops, cron jobs, without an LLM. What does an LLM do and how does it work? Keep asking those questions. And I think most people who know that they have to maintain a system even when it's finished, we tend to do it manually first, by hand, step by step. We understand what goes into it, what comes out of it. And then once we get that fundamental understanding, then I think it's okay to outsource it to another tool or a piece of automation. That fundamental loop doesn't change. Thank you all for hanging out with me.